1 second, guys. We are waiting for the last folks to join. All right. Good morning, folks, and good afternoon for those of you who are on the East Coast. I know some of you are there. I don't believe today we have any participants joining from India. And Thomas, how are you joining from Malaysia today? So today is the week 8 or the week 9. Who remembers? 8, yes. It's the week 8. And we are going to do now. People had requested that we, oh my goodness, yes, indeed. 1 second, I'll turn on the TV. 1 second. I'll start the screen sharing all over again. Okay, guys. Oh, what just happened? Yes. I was requested last time by many of you that the projects are coming. These are big projects, complicated projects, and we are all behind. Many of you are on project 1, many are on project 2, on 3 and 4. And here we are. We have quite a few projects that have been released. If you recall, we started with creating a vector database, then indexing, doing a search engine, then doing multimodal search, then doing RAG, then doing active RAG, and then doing image generation, and about writing an essay based on the search results, an essay that an 8th grader could understand. Now, some of you asked me for tips on last week. I'm going to give you those tips, but today is a very interesting topic. While we have been throughout this course, I hope suitably impressed as well as frustrated with the powers of large language models. So these large language models, they do seem to deliver on the promise. After a lot of careful preparation, they don't just sort of work out of the box, or their performance isn't that good. But for the particular problem that you want to solve, if you try hard enough, if you do good preparation of data, so on and so forth, fine-tuning, prompt engineering, etc., instructions, you do get to make them work. That's a state of the art in 2023. It isn't yet a level at which you can say, this is what I want, and just do it right the first time, or something like that. I don't know if that will be feasible someday, most likely will be, but today we are not there. So part of the lesson or the learning in these boot camps was to realize the struggle part of AI, that it's a lot of experimentation, it's a lot of hacking, there are many, many ways of doing a problem. So for example, I introduced you to image bind, and many of you used image binds. How many of you were happy with the results? Reasonably happy with the results?
Of image bind?
Of image bind. And did anybody try an alternate approach to image bind? What did you try?
So we've used specialized models for different things like text, video, image.
And how would you then search for it?
So for example, in the image, we use the embeddings and stuff. So if you technically do a search, what we do is we map it into a regular thing like Lava, providing a description of the image.
Great. You use the image description and you index that.
So basically, all the video, image, text, what we do is they all have something similar. Like here's a text explaining what this is about. Even the videos, even the timestamps and everything, right? So we transcribe that. So we always have a commonized text domain.
So you generate using Lava and using Video Llama, you are generating the textual descriptions out of all the videos. So yeah, this was the second approach I wanted. This is great. And what did you find?
I'm impressed with what I'm getting.
Yes. In fact, what you will find is most machine learning projects are done in stages. If you try image bind, sometimes it will work quite well, but quite often you get much better if you do, just like we did for text. See, for text, what did we do? If you just take the whole text and just vector encode it, you get pretty poor performance in search. You're much better off to chunk it. But chunking shouldn't be done at random places. So you need to do a semantic chunking. To do semantic chunking, what did you do? You used an AI model to do semantic chunking. You use quite a bit of mathematics to get it right. And many of you, different teams have tried different approaches. But at the end of it, you used an AI model just to get your chunking right, even before you would put it into a vector database. Use a sentence encoder after that, right? So in the same way, when you come to images, you have to think a lot about it. What you should do is, you should ask yourself that given this image, right, what can I do? You could, one way is that you feed these images into a direct multimodal encoder like image bind. Or whenever you do that, so keep it there. The other alternative is you could use Lava, you could use Video Llama, you could use Whisper for text, for audio, and so forth. And you could convert each of these systematically into text and then ask, can I use the text to do that? So when you convert that, realize that you need to do quite a bit of instruction and prompting. You need to write good prompts. Now, these things come with prompts, but you can do sometimes better. You can do more of it. Then when you index it together with other chunk size text, for one thing, your text chunks and your image descriptions would look pretty much textually of the same size, or video descriptions would be of the same size, right? And when you do that, you get another search results. Given that you get these search results, what do you do now? Right? Two ways to do that. You can hybridize the two results together, isn't it? Just as in search, we hybridize the results coming from keyword search, traditional search, and AI search, and passed it through a cross encoder to see what is more relevant. Now, it turns out that there is no multimodal cross encoder, but what we can do is take a mixture of both the results coming from two different approaches or multiple different approaches. One lesson, if you remember, that we learned in the ML200, the comprehensive intro to data science, was ensembles are a good idea. Do we remember that, guys? Try to use ensembles. And so what I'm suggesting to you is, don't, like, whenever you have multiple approaches to a problem and your hardware and your budget can sustain it, unless one model is significantly better than the rest, in which case just use that one model, or one model is all you can afford on your hardware, or one model gives you accuracy that is good enough for your business problem. In all of those cases, the problem is solved. You don't need to use an ensemble. But on the other hand, if that is not the case, then, and you're unhappy with the results, you can always boost the results by using a committee algorithm, an ensemble approach. Right? Always use use a mixture of these sort of experts to get your job done.
But this image bind, that's what's supposed to do. Combine your text and image and give the hybrid search.
Sort of, yeah. But it doesn't do as, if you look at the text that comes out of the image, is clip-based, clip-like approach, right? Whereas Llama gives you, see, if you look at Llama, how does it work? It is itself a multi-stage approach. First it does image segmentation. That segmentation detects things in the image. From that, you feed it with instructions to a large language model to get a fairly good textual description of what's happening in the image, right? Whereas just saying picture of a sunset, it'll be much more precise. There is a setting sun, there's a waves, there's birds in the sky, there's a kid playing, right? And there's a runner running, and so on and so forth. So it would be, because each of the objects is identified, you realize that you would get a lot more out of it. And actually, that's the reason I had covered that paper in the last course, the neural architectures course, because I was hoping that you guys would use it here. Right? And the same thing applies to Video Llama. There, what you're doing, you're benefiting from the full power of audio, video, and all of that going through the Q format and so forth. And in a way, you can argue that ImageBind is also doing the same thing. Right? But you will realize that just do it and see what happens. Just do that and see what happens.
You can do that same text description, whatever you get from Lava or to the image.
Exactly. And so what you can do, and so one easy way to hybridize it is this. See, here's the thing. An image, create a vector embedding, feed it into ImageBind. From the image, take a circuitous route through Llama, generate a detailed text, and use that also into the embedding, right? ImageBind. And now what happens? When the search result comes, it may pick either the image or this. Let us say it picks this. But both of them are pointing to the same record, isn't it? And so in your search result, you'll just have one entry, namely that image.
So, as they're both in 768 dimensions, can't we just add the text embedding and the image embedding?
No, but why? Why? Because whenever you average, right, you sort of lose some resolution in a way. Just literally have them as two vectors. Either of the two can qualify as a search result, but they both point to the same object.
But relative to the average of its, if it's neighboring search results, the text, either the text caption versus the image embedding, there might be something that contributing that.
Yes, you could try that actually. Because you're doing the image, like you're passing it through ImageBind, you may consider before you store it or index it, average the two. I don't know whether it will give you a good result. See, this is it. It's all empirical. You have to experiment and see. But try that. Maybe averaging is a good idea.
Can I share a find?
Yeah.
So there's a very so there's obviously, I mean, these days there's a bunch of people writing on LinkedIn and all that kind of stuff, blog posts. We came across a blog post and it made a lot of sense. Basically, it says one is the fact that you've taken the content itself and you have indexed that, right? But even for like text or whatever, right? When you look at a PDF or something, you know that the audience is going to come and ask questions about this thing. So in the ingestion pipeline, if you run it through another LLM, give it a piece of text and say, what questions does this text answer? And let's say it returns 10 questions to you. You can actually take those 10 questions and embed and put a vector embedding. And it's very possible that the user, when they ask a question, it'll hit the question itself, but it points to the same record. So the fundamental concept was that content itself is not just the index. You can run other things around on the content on how you perceive the content is going to get used by using LLMs or whatever, like describe this picture.
That's a feedback loop, RLM. That's what you are saying.
Yeah.
That you can add these questions as a feedback loop.
Right. But in addition to this, was that let's say you have a speech versus a song. Right? The way the LLMs will ask the questions, one could be like, what is the content of the speech? Therefore, you'll need some embeddings from like audio, like from whisper, essentially. And then you can have one from the song, which talks about like the musicality of it. So there are two different models that focuses one on the content that was said versus what's happening on the background. Yes. We can just use one LLM to generate all of that.
Exactly. So that's exactly the point answering ImageBind, that yes, ImageBind will do a good job. but that's only on the content.
Yeah.
But then if you enrich it by saying, what else can I say about this content and insert that into ImageMind or any other indexing?
Exactly, feature extraction, and then you see.
Yeah, exactly. Feature brings back to the old message we have been doing all over the months. Feature engineering.
Can you like
Yeah.
Sure.
Feature engineering. See, guys, so anyway, for those of you who are remote, Satyam pointed to a blog which said that, amongst other things, when you get a text, for example, you can index the text, but what you can also index or vectorize is give the text to a LLM and say, what questions can I ask about this text? What questions does this text answer? Right? And so LLM will produce some questions. You can do that. You can try this experiment out with ChatGPT or something. It will produce a list of questions. And then you can index those questions also, pointing to the same, obviously, content record in the search results eventually. So it makes for, sometimes you'll get a much more direct hit in that. And in this context, since you guys brought up this discussion, one other way, and that is a segue into graphs and a semantic web, you can actually use LLMs to do extraction of semantic web content, like triplets, the ontology content. And what used to happen is ontology extraction was an extremely manual process. You would take a bunch of domain experts, lock them in a room. The visual mental picture is keep them hungry and thirsty and starving the whole day and say, unless you come out with 1,000 triplets, you're not going anywhere, right, a day. So it was a very, very painful process for any domain to become a knowledge graph. And which is why good mature knowledge graphs are hard to find and they're relatively incomplete. They are more abandoned knowledge graphs than they are actual, by orders of magnitude than they are actual completed knowledge graphs. But one of the things that actually here at Support Vectors we are experimenting is, can we use LLMs to extract those triplets? And we had pretty good success with it actually. Yeah. And once you do that, then you can bring the power of graph theory, complex network analysis and graph theory, to rationalize those triplets and see which ones are much more important by looking at the centrality measures in the graph and many, many things you can do. And then, of course, subsequently follow it with a graph neural network embedding. And then even the graph becomes, those ontological elements become embeddings at the end of it. Right? So that's a long journey, and we go there. Anyway, so this is, we just discussed what are the lessons we learned from the previous thing. So the big lesson, or the one lesson throughout machine learning, if you remember, I've been telling you that you can squeeze a lot out of any algorithm with good feature engineering. Okay? If you remember, we started out long, long ago when you did the first course on machine learning, we did linear regression. And then literally your first lab was, there was one data set that was a straight line, linear. What was the next data set? It looked like sinusoidal, right? And a straight line equation couldn't solve it. A linear model couldn't solve it. What did we do? We did some feature engineering. We just expanded the basis to polynomials. And the moment we expanded it to polynomials, a linear regression equation, a linear regression model began to work. You just had to expand the basis set. And we have been seeing this over and over again. The river data set, if you remember, was our, I hope, memorable event where you learn the power of solving complex problems with simple models. Now, in this LLM world, obviously, there is no such thing as simple. We are looking at very, very complicated models, huge models. And actually, next year's models will make this year's models look tiny. So, but there is no denying that if you want a good product, think of all sorts of ways to improve, right? And so I was hoping that you guys all would have some level of dissatisfaction with the results or with what you have done, because you would see that it leaves a huge scope for improvement in the models that you build. Anyway, so today we will move on to my usual thing, guys. Remember, we are shapers. We are here to help you, right? You are, by now, you must have realized that doing this boot camp is a little bit like climbing Mount Everest, right? So we are your Tenzing Sherpa, carrying your luggage to the top. Right? So this is who we are. Just as a quick reminder, guys, that we not only give training, support practice is also into consulting and guiding corporate things. We also provide corporate training wherever you work. If your team members are talking about, oh, which is a good place to get training, we can tell them that training can come to you. We can come to your places and give you training. We can also give seminars, lunch and learn sessions, whatever you want. And we'll be happy to do a few sessions free. This course is about, I keep reminding you over and over again, this course is about the gap. In all the previous courses, you learned the theory of machine learning. You did some labs, some simple toy examples, and proof of concepts. This entire workshop, a boot camp, is about the vast journey you have to take when you go from a proof of concept to an enterprise scale, robust and high performing architecture. And you realize that that is a different, it's an entirely different kettle of fish. So it takes a lot of things. This is again a very, very quick reminder. Many things go into a proper AI-centric enterprise. There is the people, the data infrastructure, the models, the ML platform, ML ops, security and compliance, analytics and visualization, ethics, many, many aspects go into an AI system. And its processes, the whole ML ops stack is pretty complicated. You have the code.
Can you go back to the previous lecture once? One element which I don't see here is you have security and compliance.
Yes.
Privacy and security are becoming paramount importance.
That is right. So usually, yeah, you're absolutely right. I put the privacy under the compliance because of all the GDPR and so on and so forth. Absolutely, it's becoming very paramount. And then we are, what's a cycle of workflow? So people are trapped based on their skill set in one of these three cycles usually. They are either a data science cycle, building models. They are in the data engineering cycle, generally involving a lot of work, right? And then you're in the MLOps cycle. And quite often when you hear of a great breakthrough or somebody coming out with a remarkable platform that can do magic, you often think that there must be a couple of really good algorithms sitting there. What people forget is algorithm was one part of it. To get to a remarkable, usable, practical product, it takes an army of engineers to make it happen with very different skill sets, with infrastructure, hardware, networking, MLOps, like DevOps, data engineering, systems engineering, microservices, UI, all of those things go, not just algorithms, to support such a pipeline. So again, it's a pretty complex world in which you ingest data, clean, validate, transform, label. Then you do the actual training, which you notice is one part of it. So there is a huge part, the data stage that comes before the training stage. Then you do the training stage, experiment, train, tune, and then you have the deployment stage. You need to properly manage it. Now, today I would like to emphasize the use of a feature store, guys. As you are creating all of these data, get into the mindset of a feature store. When you do the mindset of a feature store, you will realize that you will be more aware of feature engineering. From an image, for example, how many features can be extracted? You can obviously convert the entire image into a vector, right? What else can you do? You can pass it through a VLAMA and then extract a textual description, a proper good textual description, or you can pass it through blip2 or whatever it is and get good descriptions out of it. Those are features. What else can you do about that image? Obviously, there can be metadata somewhere in the XF files. You can, the one obvious feature is when was the picture taken itself, if you have that. But then more than that, if you are familiar with computer vision, you can do feature point extractions. How many of you know what feature point extraction is? Only one, it's Praveen, right? So see, there was a world of computer vision way before deep neural networks came about. And people were doing a lot of feature extraction from images. So those things are still, believe it or not, a lot of those methods are still the same old methods. That, and it's a pity that most people don't know about them. Right? So learn about feature point extractions, right? It's very important to know these things, that you can extract those. You can do then image segmentation. And one of the features you can extract is literally the labels. What are the things in this particular image? Isn't it? That itself is one hot encoding in some sense. You can ask dogs, are the dogs there in the image or not? So you can do a lot of feature engineering, is worth doing. Monitoring and training, of course, you should keep doing that. And one good thing with Ray platform that we are standardized on for this bootcamp is it gives you pretty good monitoring capability. I would say for a young project, new project, it's pretty good.
So,
Yes.
good question. Feature engineering almost always is going to be associated with mobile data sets, or can
No. See, features go into, in a way, see, when you're doing clustering and so on and so forth, if you extract a whole lot of meaningful features, you could be doing clustering in a much larger space of those features. So,
in the previous slide, so if you look at the traditional models versus the LLMs, then for us, like we would skip the training stage.
no, training will become fine tuning. Right. And in fact, you would fine tuning and feature like prompt engineering, instruction set. So that will become a large part of what you're doing. Okay, guys. Yeah, go ahead.
RAG, which is sort of a prompt tuning, right?
RAG.
Yeah.
RAG is it comes under the family of prompt engineering.
Yes, and that gives better results when you can use the results of your prompt using RAG.
Much
in
better.
that pipeline, you could replace the training with RAG and prompt tuning.
Oh, yes. So when people use the word, see, when these alliances form and they use words like training and this, they generally include all of those techniques that you use along in your journey, creating your architecture and so forth. And yes, guys, these things are like, let me give you guys a hint. Your last week's lab was actually a 20-minute lab. You have a whole week, and I'm giving this week for you to catch up. But believe it or not, the entire thing that I gave you, the coding part of it is barely half an hour or 20 minutes. But the reason I gave that is because I wanted it to be the lab where you'll realize the importance of, can somebody guess what?
Prompt engineering.
Exactly, prompt engineering and instruction tuning, exactly. That's what it is. I gave very specific example. You need to write something, an explanation or a description or an essay for an 8th grader. Implicit to that is, what are some of the things implicit to that? You have to use a child's language, isn't it? It should not contain, and now, I don't know how many of you thought about it, it should not only be easy to understand. How would you know that it matches a 8th grader's language? What's a metric? Vocabulary is one, but believe it or not, there are actually algorithms that measure the readability of a text and they quantify it with what age group can understand that text. I wanted you guys to explore that. It goes back to old methods like the Fletcher score and so on and so forth, which have been used for decades, to much more modern methods, which use transformers to evaluate whether how readable or comprehensible a text is. So think about it this way, guys. When how many of you use things like Grammarly? Right? Most of you do. Does it tell you at some point how readable the text, comprehensible or easy to read the text is? It's one of the measures you get, isn't it? How do you think that's happening? Right? So there are means to do that. And so implicit in my requirement is that your essay should be understandable by an 8th grader. If you really do it well, that is what should have hit you. Right? How do I know that it is understandable by an 8th grader objectively? And there is a whole world that looks into that, of transformers and so on and so forth. So if you take that angle, of course, you'll be doing much better. Now, the second part of it is just image gen, which I'm sure that after the diffusion models, you found it quite easy on your machines to do, so long as you have a 4090. And now I believe Sukhpal has been having a roaring business of making machines for everyone. Is there any team that still doesn't have one of Sukhpal's great machines? Every team has that, right? So there you go.
But with even 4090, you need like huge RAM. Like I'm not able to run so many things. You need to have like 96. Like I have 32 GB RAM, and all the time I'm running into OM.
Oh my goodness! If you have 32 GB RAM, you are in the you are in the begging categories.
Yeah, you know, I ordered like one yesterday because I'm not able to run in parallel like anything.
See, guys, if you're doing machine learning, start with a machine that has at least 200 gigs of RAM.
I don't think people have that. I have 96.
96 is the better to begin with.
96, yeah, is a good starter, but see these models.
But on 96, I can't run ingestion and inference together.
Yeah, you should have. See, guys, here's the thing: RAM is cheap these days. When you're building a new machine, if you can, start out with 256, or better still, go with 512 or so forth.
Yeah, you are saying RAM, read it.
RAM.
The normal CPU RAM.
How much? I think 30.
I ordered yesterday.
Some more, huh? Okay. But generally, so a stable diffusion should be able to produce an image in under about 30 seconds. Just enough to be a banner to the picture, low resolution image. Are you guys getting that?
I'm getting in 3 seconds to 7 seconds, but the problem is it's the longest poll in everything that we do.
Yeah. And I hope you're putting it behind a messaging queue, these jobs, image generation jobs.
Yeah.
Yeah.
Doesn't get your response quicker.
It doesn't. Yeah. It doesn't get obviously, you could do better with a H100.
But how are you guys doing with the single 4090? Is that what do you know? Or you need a dual card?
No, diffusers don't do
Not
particularly better with.
regular for the project. So far, you are finding
14090 is enough.
Yeah, but like you can't run in parallel as same.
Ingestion and inference you can't do together. Like if I run, there's just no way I can run text, video, image, everything together while running inference. That's never gonna happen.
Yeah. So guys, we're coming to today. Oh, by the way, now you guys will start using the big inference server. We have completely cleaned it. You will get one Docker image. You have to set up your stuff in that one Docker image. You will not get access to the root machine because yesterday, Praveen, myself, Hamad, we were looking into the machine and we found just about everybody's fingerprint on it. There were multiple operating systems running
So
on
you
it.
reinstalled everything. You
Yeah.
reinstalled
Yeah,
everything.
we wiped everything. And now there is a Rocky Linux and Podman, which is Dockers. And you guys will just get a Docker to run your load on. Now, thanks to Sukhpal, the whole machine set itself on fire, quite literally.
But when you do
Dramatic.
Podman, I think Podman and Podman, Docker, all of these guys will put other artificial limits on it. In the execution, it doesn't allow it to like.
No.
use-
When I created those Docker things, I gave blanket thing, no memory limit, no
I see.
CPU limit, nothing.
But I thought that depends on how you run the containers.
That is right. So from the cockpit, when you fire up the container,
Yeah.
it basically comes out with no limit mode. no limits.
I'm sure, is check the Docker running, then able to run the GPU.
Yeah, you can.
Because you cannot by default run, Docker on.
Yeah, but
You have to enable the GPU support.
See, GPU support is there in the host machine.
Right.
And therefore, the Dockers, because they are, so on Fedora, we are putting just a Fedora Docker. It inherits everything. It's a very thin, very small. It's not even 1 gig.
when
It's
you
a
do
few
a
MBs.
Docker run, you need to say GPU.
Oh,
Yeah,
yeah.
you have to enable the device support,
Yeah.
or CUDA device support on.
So, all right, we'll all learn it together. Maybe I'm missing some nuances. I'll learn it from you, Prakash. So there we go. So guys, today is, many of you requested catch-up time, guys. So this week I was going to release a very interesting project, but I'll wait it out till next week. But I'll give you an idea of what that project will be, and the projects that are going to come will be. November will be a fun month. Now you guys are, I think, into the flow of things. But today I've deliberately kept it no project, just finish your existing projects. But we'll do a few paper readings. See, these large language models, impressive as they are, they also have weaknesses. They can be very easily attacked and poisoned. There are countless stories in which, people have released chatbots, which were soon made into completely hate-spewing racist entities. People have learned the hard way that yes, these things can be manipulated.
But that can only happen if you use reinforcement learning or you're trying to do something with it.
That is right. So some of the early attempts are foolish enough to indiscriminately take the user input and adapt to it.
But you must be storing the data somewhere, right? Because in your pipeline, you wouldn't just change the model on yourself, right?
No, the model keeps going through, some of the older models, right? They were going through continuous
Learning.
retraining.
I see. So as you ask prompt questions, it'll try to.
Yeah, that's right.
Is that how some of the new ones like Mistral and stuff work?
No, they didn't do that. Mistral is a standard vanilla open source model.
Yeah, because you load a new model, right? I mean, the minute I kill the instance and I bring up a new one, basically it's going to revert back to the.
That is right. That is right. Unless you save the weights. But the
Yeah.
thing is, you can choose to continually update the weight. See, what happens is, imagine that you have one production instance. Input is coming in some engagement, and some user says, oh no, this was the wrong answer. This is the right answer.
I think.
And you capture it. And in parallel, you're running another model on which you're doing reinforcement learning. What will this model learn after some time? Right? So you can't really trust the user. They are having fun misguiding you. Right? So things like that. So today is about adversarial attacks. We'll read 2 papers on adversarial attacks, and I will make, oh, you like the topic? Okay, yeah. So how can you do adversarial attack? Mathematically, actually, it's beautiful. The reasoning behind it is quite beautiful, right? So I will first do one of the early papers of 2014. This whole adversarial attacks were independently discovered by 2 different research groups in 2013, multiple research groups in 2013. By 2014, giants like Ian Goodfellow started thinking about it and coming up with systematic approaches to attacking neural networks. And we will, in fact, I won't utter those words because they are literally part of your paper reading, silent paper reading today. Please do take the paper reading very seriously. It's an important topic, guys. You're playing with fire. You'll burn yourself in your projects if you don't know what risks there are and how it can be attacked and what defenses you can have and so forth. It's a topic that you should go through once. So I'll do the paper reading. I'll make the implementation of this as an optional project. If you have time, do it. If you have interest, do it. Otherwise, do not do it. And the implementation, all I'm saying is reproduce, play with the they're very good libraries like Clever Hans and so forth. Use that to craft attacks and defenses.
What's the idea?
We'll come to it in the paper. After the paper reading, we'll do it. It's so in the library, one good library is Clever Hans. Clever Hans. So I'll tell you a story. where the word clever Hans comes from. Anybody knows the story of clever Hans? No, I haven't told you the story. Okay. So there was once a horse, and the owner of the horse was convinced that this horse understands human language and can do arithmetic. So you would ask it, clever Hans, what is 5 plus 7? And the horse would go tuck, 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 tuck 12 times. And people would be absolutely amazed. And there was no trickery, like it was all very honest. And he would do it on stage, and it became quite a sensation. This clever Hans, this horse that could do arithmetic and could basically give yes-no answers to things. And people are puzzled, and they said, how is it able to do it? Well, finally, the resolution came when a psychologist, a behavioral psychologist he also tried for a long time, and the horse always came through. And then finally, he resolved how it is. He created a completely dark room in which the horse couldn't see. And then he would ask, what is 5 plus 7? So, or what is, let's say 2 plus 3. And the horse would go, duck, 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 and it would just go on. Right? So that's where you get the clue that what the horse was doing is, it was looking into people's faces. And it picked up the behavioral or psychological cues that told it when to stop. Right? And in many ways, you can think of these, I don't know, so that's a clever Hans thing. Now, if you think of these deep neural networks with all the reinforcement learning, they all seem to be clever, right? They seem to think, but we know that they don't think, right? So in many ways, they are the clever Hans. So today we'll do paper reading on these adversarial attacks, and what is the beautiful way of interpreting why it happens, how to avoid it, and so on and so forth. Guys, I am really hoping against hope that today you guys brought some new finding to share with the community. Cambrian explosion. If you haven't, there are still 5 hours. Please go find something of value that you can share and enrich the learning community with. So remember, guys, we are a learning community. Bring that. Again, there is a team presentations of the work. Which team would like to present? Last time, Satyam, you said next week.
We can present something.
Some things, okay. Which other team? How about you guys?
We have a lot of pieces, but we have to
Bring it together. Praveen, you have presented. Athiras, yeah.
No, we have a lot, but I have to get ready on a for inference server is, I don't have a machine to.
That's nice. Okay.
I got my machine this week, so I'm setting it up this week.
Yeah. How much memory did you put in that?
96. So
Right.
I'll run into the same machine.
I'm
Double
not
it,
yet.
double it.
I mean, yeah, I'm running into inference and ingestion.
Yeah.
Double it,
The jobs
Anurag.
itself are ready. Just have to run.
Double it. It's not worth hitting your head against the wall. And which other team? How about you, Albert, your team?
We're not ready.
Not ready. Huh?
Next week.
All right. And Prakash, how about your team? No?
Yeah, we're not fully ready yet.
Okay. All right. So there will be one from Satyam's team. All right, guys. So that's the plan. And what's the journey we have done so far? Are you noticing there are lots of milestones we have crossed so far? We learned text extraction. And we realized that even text extraction is an AI process. It's not that easy to convert from multiple formats and take it out and make it into a proper chunk. We learned about vector databases, ANN indexers. Can somebody give me an example of an ANN indexer? Oh, FAS is, yeah, indexer, but internally, what are the pieces that it could use? Indexing algorithms it could use? IVF, HNSW, flat, plus that, and so forth. Excellent. Hybrid AI search. What is this hybrid AI search? Anyone?
What we did.
Elasticsearch plus.
Yes, yeah. And putting it through a cross encoder can do that.
Semantic plus keyword.
So you pick up the strength of both. Right? And what is multimodal search? Example of that? Yeah, giving an image, for example, and getting lots of descriptions and other images and videos, or giving a text and giving images. Like we did that. And retrieval augmented generation, RAG. We know now it is putting. So the more technical way of saying it is that you benefit from or you augment the knowledge base of a LLM. See, LLM, when it produces an answer, as a next word predictor, it's predicting the most statistically most likely word. Even if you sample over it, it produces a text. In a way, you can say that the text that it produces in some effective way is being generated from the weights and biases, the parameters that is stored in the model, right? Somewhere in there, in ways that we don't fully understand, the knowledge gets encoded. And it is using that. So that is parametric knowledge. But then you have access to a vast amount of non-parametric knowledge. When you take an LLM, it is dated. You train, for example, you may have trained the LLM in 2021. But a lot has happened since 2021. Wars have happened, right? And new wars are mushrooming all over the landscape these days, unfortunately, right? New discoveries are happening, good things are happening, right? Good and bad. So if you search for it, search for answers, you would realize that you don't get the best answers from a LLM if its knowledge is dated. But we just did RAG. I mean, we did hybrid search. And the question is, hybrid search or search engine was one way of getting answers. Asking an LLM is another way of getting answers. Why not combine the two and smarten up the LLM? Right? And that idea is RAG. To further, and it also is a cure not just of staleness of data problem, but also of hallucination. You can further reduce the hallucination by doing active RAG player. Then we went into things like memory efficient fine tuning, right? QLoRa and so forth, right? Quantization, etc. Then we talked about diffusion models. Beautiful theory, but by the way, guys, you realize that have you noticed that behind all of these models, while the models are fun and we can go get them from Hugging Faces and we can fine tune it with data and do a lot of coding, there's also beautiful mathematics. There's beautiful ideas there. Diffusion, again, and as you will see today too, there's good, like diffusion models are based on a key idea from non-equilibrium thermodynamics. Right? Literally the diffusion process and its thing, and how would you reverse it and so forth. And they build on each other. You realize that diffusion models wouldn't be possible if we didn't have the world of encoder and decoder-like thinking. The unit didn't exist. Or if we didn't have clip or guided a text transformers, right? Or something that would create a vector out of text, and we could look at the alignment between this image and that vector and so forth. So everything that you're doing builds upon it. The next generation algorithms built upon it. And today, when you look at stable any diffusion model, now we are haggling over this guy seems to have 6 fingers, right? That sort of minor details. But all of this would have looked miraculous in pre-pandemic days, isn't it? How many of you thought that this was possible pre-pandemic? Very, very tough, right? Transformers were just taking off. They were doing good things, amazing things. They're beginning to do amazing things in 2019. But we're in a completely different world now. There's a Cambrian explosion of things that you can do with transformers. I am not able to catch up. I sometimes feel I learn more from the news that Praveen and Patrick bring to me and others bring to me. I often miss crucial papers and then I have to run and catch up on them. So this is the pace at which things are moving. So
if you go back to previous slide, so request if you can The paper reading I was suggesting you, if you can index or roadmap all the paper,
Yes,
that would
I
be.
will. I'll do that. All the papers will be on the course portal. Not only of this, but from the deep learning course also. So I've over the years, over the months, I've forgotten all the papers I've taken you through. I sort of visually, mentally remember what are all the key milestone papers I must cover. But then I forget which ones I did and didn't cover. If one of you can just give me a reminder or a list, Athira, would you like to take that task? Because you must have noted down all the papers that I've covered in the last 6 months. Please give me that list and I will then add it to the course portal.
No, one more, it's not just a list of papers.
No, why is it? It's with
Yeah,
description.
why, like click, like how one or the other, like
Yeah,
how the image, text, audio, video, you could have a categorized, how each paper will fit into like what they do, some kind of
Yeah,
tutorial.
I'll do that. I'll put little descriptions
Yeah.
or things like that onto the cards. Definitely, it's a good value. And guys, are you finding the course portal useful? No?
I haven't used it.
You haven't used it. Okay, use it. You'll find many things. By the way, Jenkins instructions, Chandra gave, I've uploaded to it. So some of you are struggling with Jenkins on the Rocket Linux, so you can now follow the instruction. I'll also upload the instruction. Some of you want to know how to load Wikipedia into your project. So I'll release the code today for the Wikipedia part.
I'm doing a GitHub action, so once I complete, I can answer.
Oh, yes, please do.
So CI/CD both now it builds and deploys to my server. So, but it's still in the working.
Really? Oh, I would love to learn that. Praveen, if you can create a good tutorial for that, let's share it.
The GitHub action?
Yeah.
GitHub Actions.
So that's all it should be. Once you, every time you are pull request check-in, it should does the continuous and whenever we release it deploys to myself.
GitHub Action, if you use the default server, it takes a long time. So you probably want to use your own servers or something like that. Otherwise, it takes endless.
Oh, interesting.
Anything that's free.
For free, that's what they give. It gives up actually. Unless you buy enterprise.
So
Yeah, they all have the catch-up model. Right?
Everything unusable is available for free.
Okay, guys, so today's topic is very interesting. What do you see on the left? A cute little panda, right? And what do you see on the right? A cute little panda. But what the machine sees, what your neural network sees is, guys, 1 second, guys. Sorry, guys. So I'm almost done. What you see on the right-hand side is also a panda. But what the machine sees, have you noticed something interesting? What is the machine saying at the bottom? It's absolutely sure it's a gibbon.
Yeah.
What's a gibbon, though? Let's find out what's a gibbon. I don't know. What does a gibbon look like? Let's see. I have known about this paper, and curiously, I've never looked at a gibbon. Oh yes, images of a gibbon. Surely you would agree that this thing is, or this thing, let's take this one. This is not looking like a panda at all, isn't it, guys? Right? Or this is not looking like a panda at all. If I just put it on the left and the right hand side, do you notice that a panda and a gibbon, they look quite different? And yet the AI with great confidence says, I'm looking at a gibbon. And what did you do? You took the image and you put in some hidden noise that's not even perceptible. It is just below the perception threshold, the human eye perception threshold. So you can't see it, but the machine can. And it has completely altered its inference And so your image classifier is misguided now, right? That's an example of an adversarial attack on your model. Adversarial attacks, it turns out, are common. Now, it's a very active field of research. Why they happen, we don't fully understand. There are different hypotheses. The hypotheses that I find most plausible and I like the most are two hypotheses. One of them is called the dimpled manifold hypothesis. And I've given a paper here. The other one, I didn't give it to you read because these are both relatively dense papers. You'll have to pay some attention to read it. So 2 paper readings are enough. The third one is a manifold curvature hypothesis. It says that mistakes tend to happen when manifolds develop huge curvatures, or they become highly complicated. Right? In a way, they tend to sort of try their best to fit to the data, and they go around points to just fit. Right? So during the learning process, there also are learning mistakes. So read about, there is a good survey article somebody wrote, very nice, and then there's a clever Hans, but there are many resources. If you are interested in all those resources, we can share with you a bibliography of all the resources on this topic. So this is it, guys. Huh? With that, I'll let you go and enjoy your silent reading till 2 o'clock. These are 2 dense papers, guys. Do it. Please do study these papers. And then, of course, continue to do your projects. You all requested that we don't do any new projects, so this is it. I'll give you an idea of what is coming next. We haven't dealt with tabular data. Right? And so we'll do it in stages. First, we'll give you this problem. Suppose there are lots of forms that have been scanned. Create a pipeline that extracts data from those forms, meaningful data, and knows where to do it. This will get you into all of some details of OCR. It's a necessary topic and the LLMs do, these transformers do a pretty good job of it these days, much better than the old methods could. Right. So we will do one project on OCRs. The other project that you will do, and we have only 4 weeks left, the other project that you'll do is you will have to create, you have 2 choices. One thing is take all my videos on YouTube. They're only 100 odd videos, small data set, and create a virtual instructor out of it, AI instructor out of it. So you can chat to it and ask questions, and it should be able to answer your questions and guide. Be a virtual teaching assistant.
Put a facade on top of ChatGPT. Put what? Put a facade on top of ChatGPT.
Yeah, and of course, don't use the OpenAI, Bard, or cloud models. See, guys, with those things, yes, it is easy, but trust me, at this moment, they are very cheap. It won't be like that because it's costing them a lot. The moment they make sure that you have forgotten how to do all of this yourself, that's when the prices will go up, right? But think about it this way, guys. How many of you remember, suppose I were to ask you 5163 times 218976, how many of you can just do it? Right? Did you know that a generation ago, people could? Yeah, and it's very easy. Even if I say don't do it exactly, I'll make it easier. I say just do it approximately. You should be able to do it approximately. And if you use common sense, it is nothing but approximate means rough approximation. Just put it in scientific notation. You're multiplying, 5.6 with something, round off. You can do it in your head and have an approximate answer. Even better, if you remember your log and anti-log table, just a few key values, certain milestone values, you'll be able to do that. Right? Easily. You could do all of this mathematics. It used to be the trick before electronic calculators came about. What did electronic calculators do? It made arithmetic idiots out of all of us. Right? was shocked when I was giving a lecture at Syracuse University. I remember many, many years ago, and that was 20, 30 years ago, when I asked, what's 77, right, divided by 11? And I saw one kid bring out the calculator and start doing it, right? So it shouldn't be this bad. So you lose something, guys. Today, you're using large language models. I notice that most people don't trust the text they write. They will write the facts, give it to ChatGPT or whatever, and say, write it. Right? And then they will generate letters and so forth. And even, I mean, practically everybody seems to be doing that. Right? So nowadays, when I get an email or a letter, I have to scratch my head and say, this looks pretty sincere. Who wrote it? That was not a question we used to ask. Okay? So you lose the ability, guys. Soon what will happen is we'll lose our literacy completely. And that is a broader thing, but computer science, you guys are AI experts. Soon you won't have any AI expertise left if you just keep relying on these APIs. All that will happen is some of these companies easily will become $100 trillion companies. Their wealth will be more than all the nations combined. Right? And the rest of us will all be a nuisance that they have to tolerate on Earth. Right? Anyway, that's a poetical statement. I shouldn't make that.
There'll be a lot of William Shakespeare.
That's a William Shakespeare.
So-
Go ahead. So somebody is saying something? No. Okay. All right, guys. So
Yeah, Asif, I have a question. This is actually in relation to using the APIs or whatever LLMs and prompt engineering. You know, like especially ChatGPT and Bard or any LLM, they are heavily used in documentation. So in relation to an earlier discussion, right? If I just give some code, right, a Terraform script or some long script, and I ask it to document it documents, and I can even say, you know, create 10 FAQs out of this, or we can basically create any level of granularity in this FAQs, right? And I also came across a term called AI generated prompt engineering. Is that even real, or what does it mean?
No, it is real. Actually, that's a very recent breakthrough. It's very, you're asking about the AI generated prompt engineering. Recently, and in fact, the paper I read, but its name is escaping me. The gist of that paper that came out, quite interesting, is that you can create prompts for LLMs by using LLMs, sort of a bootstrapping process. Because the prompts that the transformers generate are actually more systematic and better than the ad hoc techniques that we have developed. Go ahead.
I want to share an experience. Recently, we had a hackathon last week. One of the things that we did is we were supposed to do a search. We have this thing called Terraform scripts.
Yeah.
And we wanted to create a chat by which you could ask in machine language, in natural language, a question, that it could generate the Terraforms on the fly.
Yeah.
What we realized very quickly is what the user was inputting, we couldn't just directly feed it to the LLM. So what we did is we created a knowledge space of the known. We did a search in that and we picked that up and used that to create a prompt for the LLM.
Excellent. Yes.
Regenerated a prompt and then fed it to the LLM and gave it the data source of the public repository. And it beautifully summarized it and gave the results perfectly. So we realized that you could use the LLM to generate a prompt with the rack. So we got the data out from a vector, we saved it in a vector DB, indexed it, searched knowledge search, and used that to generate a prompt, and then fed that prompt to text price and it gave us beautiful results.
So usually, by the way, you should talk to Srinath. He did a project exactly like that. The basic knowledge is this field of text to SQL generation, natural language to SQL, is a very active area of research. But our state of the art today is exactly what you discovered, that if you give it just natural language and ask it to generate a SQL, it doesn't do Terraform. It doesn't matter.
Yeah.
So within the same class of code, then it doesn't do as good a job as when you back it up. It's again RAG, you RAG it.
Yeah,
But usually what you're saying is something slightly beyond that. What I'm familiar with is we have a way, a template, instruction that given this knowledge, given this user input, generate a script or a SQL script or a Terraform, so whatever it is, that's the way you're doing. But what you're saying is given this knowledge, given this user input, generate a prompt that you will then feed to yourself to generate Terraform.
Yes, that's what we do.
That is it. And that is actually, it's remarkable that you did it, because the paper in which said, I think the paper is auto prompting, isn't it?
We did not know what this paper, we just.
Or you just discovered it on your own.
Yeah, brainstormed it.
Yeah.
and came up with it.
I read that paper, I've forgotten its name.
Right, the
Patrick, if
research
you remember, is it auto prompting? DSP.
Demonstrates it.
Demonstrate search predictors. Yeah, I did, but that's been there for a while. Recently, there has been a paper that basically is using LLMs to systematically create good instructions and prompts. Autogen, exactly. That's the paper. Yeah, that's the paper. So you should look into it, guys. And by the way, if enough of you ask for it, two important ideas. By the way, Patrick mentioned demonstrate. I keep forgetting the whole thing.
Demonstrate search.
Demonstrate search predict, DSP, right? Yeah, that is a very crucial idea. In fact, React and other things derived are all interrelated. I haven't covered the React paper. I haven't covered the DSP, and I haven't covered the AutoGen. If you guys are interested, I will do it because they don't directly impact upon this bootcamp, but I can do them separately as paper readings. Go ahead.
As part of the bootcamp, you're already doing the prompt augmentation generation using RAG, right? I mean,
That is, you are doing it. You're doing it. You're doing it. So yeah, these are just, see, the prompt engineering has become a pretty involved field in itself.
Yeah.
And there are many, many techniques by which you can generate.
I mean, the example she gave makes perfect sense
Perfect.
because they're generating SQL or
Yes.
code like stuff,
SQL.
which
Or
with
it
the
could be
existing
Terraform,
prompts is
yeah.
going to be harder.
Terraform scripts,
Yeah.
it could be, I don't know, anything.
Yeah.
It could be.
I mean, the SQL one I follow very actively, but it's very much work in progress.
I want to know. Okay, Anuresh just volunteered to give a session on
I'll point to the
yay,
paper.
on the latest and greatest news in natural language to SQL. Anuresh, would you like to take that?
Sure.
Take your time, like in a week or a couple of weeks. Do that, yeah. Go ahead.
I shared LLM top 10 attacks
Mhm.
on the channel. If there's appetite for it, I'd like to present that.
Oh,
So that
definitely.
Also define my understanding.
Absolutely. I mean, I would consider that a classic, Cambrian explosion event. Please, you can present those facts. Would you like to do it today?
No, I'm not ready for today.
How about next time?
Next week.
Next week.
That will give me time to also think about it.
Sure. Whenever you're ready, next week, 2 weeks.
Yeah, because that will also help me understand the topic a little better. Yeah, I like to do that if there's appetite, sure.
Yeah, this is great, guys. Finally, the Cambrian explosion series is taking off. So one from Anuresh, one from Mosni Banerjee. See, great examples. Follow it. Who is the next volunteer? Patrick, which topic?
I think it's a latent consistency model.
Oh, that is awesome. In fact, are you up for it today?
I'll read it first. I can let you.
Okay, so then that could be our Cambrian explosion series. Albert.
So LangChain does all of this, right? So why do so many other?
No, knowing why it works, knowing it at the level of the paper adds value. Like for example,
Example of dynamic prompt. You create one prompt, you pass it again, you get a dynamic prompt, and you can chain it up. LangChain does that beautifully.
No, yeah, it is that. So Albert's question is LangChain does a lot of these things. See, there are two things that are happening. One is fundamental research. People are doing a lot of this in the space of prompt engineering. There's a flurry of creative activity. LangChain, in a way, is an aggregator of ideas. Whenever something new comes up, projects like LangChain, they try to absorb it and augment. So you notice that LangChain is a fast evolving open source project. and it tries to absorb it. But at the end of it, right, how many of you, by the way, initially thought, oh, why are we doing search or RAG? It is just 4 lines in LangChain. Right? The trouble is LangChain doesn't go to production. It doesn't scale.
It's a popular.
It's very popular to feel, yay, I did it, isn't it?
They're trying hard to commercialize it.
Yeah.
For
see,
demo purpose.
demo purpose is
for the
great.
presentation.
Yeah, it's great. See, ultimately, they're an aggregator of idea. They bring tremendous value because once you know that you can do it as a proof of concept, and you're capable of taking this journey of AI engineering, both the pieces are in place. Whatever new thing has been done, you have the engineering infrastructure to take it to prod.
You prototype on transformers,
Yeah.
you deploy on like Pinecone and stuff. Then you look at your bill and then you come back to reality.
Exactly. Then you start building things on your own. Right. It's the same thing, guys. Why do you plant your own trees in the backyard, right? Or make your own patio? Because try getting a plant expert to come plant trees in your backyard.
That's what happened with the cloud.
Yeah, with the cloud, the bills are killing people.
And now they're back to on-prem and moving workloads to the cloud.
In fact, I would imagine Walmart. Anybody from Walmart here with present or past experience from Walmart? Somebody was there, right? Did you have any background with Walmart? You do have, right? I heard a statement that Walmart ultimately has a hybrid cloud because they realize that you should have many things on premise to keep the cost low and some things in the cloud. Right?
The biggest example is Netflix.
Netflix, huh?
Yeah.
Oh, they have gone hybrid now.
They have always been.
They have always been.
The video content,
Yeah.
if you start paying the egress bill on any cloud provider,
Yeah.
it would be way more than the revenue.
Oh,
So the content has always been in there.
so what does Netflix use AWS for?
What you see, the menus and everything.
The
The
recommendation.
recommendation.
The AWS is used for syncing the time at which people have been looking at things and stuff like that. So what they do is, if the regular CDN is not able to access it, then they have a backup CDN to which they send the request. Seamlessly, they do the failover. But so their thing with the internet providers is that we'll put 50% of the bill and we'll give you the hardware boxes that you use as the CDN at the periphery. So that's
Right.
the business model. The AWS is all for internal, basically just management of the accounts and those kind of.
Okay.
AWS is for Amazon Prime.
Okay. Yes.
Because they don't need.
They
to
don't
pay.
charge themselves.
Yeah.
Right. Okay, guys. So there you go. So see, prompt engineering is exploding, and there are many things coming. LangChain is a great project. I mean, my first thing is go to is LangChain. I go there, see what's happening. Oh, it is doable. Then I dig deeper, go under the covers and see what makes it work. And then with that,
Even Llama index is new.
oh, Llama Index. Yeah, Llama Index does a great.
Especially
Actually,
with the RAG, Llama Index is
appropriate.
a lot of.
Yes, yes.
They have an open source thing also.
Praveen, can you check if I have added Llama Index to our course portal? Otherwise, let's do that.
They're doing a lot of good efforts. Like sharing the code.
LangChain just turned 1 year old like 3 days.
Oh, it's a 1-year toddler.
So the founder, he did a Ask Me Anything on Reddit. Everyone's complaining about the documentation.
Athira, are you having the course portal in front of you? No, it's all right. Yes. So just remember that I need to add again this Llama Index to our resources. Okay, guys, that's it. Till 1 o'clock, go read the papers. Guys, please don't start coding on your project. Do that afterwards. Read the paper. These are just 2 papers. Read it. Kate.
Do we have links to the papers?
Yes, right here in the presentation, in the PDF. It's not working?
It is working.
Oh, it is working.
In the PDF, the links don't work.
It does work. Control and then click. And yeah, so the PDF is in the course portal as well as in Slack. So just to give you, yeah. So guys, I want to take 1 moment to give you a little bit of the orientation of the course portal in case you haven't been using it. I have sort of. So guys, you have all of these resources, Zoom links, etc., etc. Then, and you have more than that. Oh yeah, so you have, guys, I put a thing called solutions and instructions, a section here. This one contains, just to give you an idea, it contains your project spec doc. By the way, that doc I'll revise, I'll add everything that we did afterwards. The sample solution up to V4. And today I'll also release the Wikipedia loader to that, how to load the Wikipedia into your database. Instructions for deploying the sample solution. Elasticsearch you have, PySpark you have, MySQL, MariaDB instruction we have. And this is the instructions for compute pipeline using Jenkins. Okay. So is there any, and then Praveen, you're contributing one instruction. What is that? I forgot. CI/CD. Yeah, one CI/CD pipeline instruction. So nice, guys. And any resource that you guys can collectively contribute, I'll appreciate it. Anything that you feel is benefit all of us.
Please add the links to Llama Index.
Yeah, we'll do. Yeah, we do. We'll do that. And so that's what we were just taking notes on. And then
just so that everybody is aware, Llama Index is doing incredible research on that.
It is.
They have actually done very good.
Yeah. Yeah.
The amount of LinkedIn updates from them is like,
Once you follow it, and Jeremy Yuga.
No, I remember the day Llama Index, when it first came out, people said that, okay, so what value do you bring? Right? And so quickly they have moved to a stage at which you don't question it anymore.
So it's like LangChain is trying to be bread and Llama Index is focused
Vertical.
on
Right. No, Llama Index is great. It's I totally am with it. And this other thing, what is this? ChromaDB, and there's some overlap between ChromaDB and Llama Index, right? Has anybody caught up with ChromaDB, the latest in ChromaDB? They are also moving pretty fast.
No, but there are other DBs. I had a list of DBs with.
now everybody has a Postgres has.
All the relational vendors have moved into.
Yeah.
Even Elasticsearch.
Yeah, Elasticsearch has its own, but Elasticsearch does a brute force direct order and scan of the whole table to find the nearest neighbors. So it will do the vectorization, but at this moment, the last I checked, they didn't have the ANN integration.
Like VV8 quadrant, everybody does hybrid.
Qdent is one of the early guys. It's very,
There's a hybrid search.
and then there are quite a few. What is it called? Nevius or something?
Milvius.
Milvius is also very good. Yeah. Actually, guys, would you like to do a comparative? Like, see, one of the things I was hoping, did anybody compare your own search engine implementation against these things? I was hoping at least you would do it against ChromaDB.
Qdent is closer because they do the hybrid searches.
No, everybody has been.
Qdent is
On Rust. Yeah. By the way, did you guys know, how many of you know, one of your projects is, your last project is rather rusty? What do I mean by that? You'll have to do your last project. You will be using Hugging Face, and you'll have to load your model and run your inferences in Rust.
Sorry, what?
Your
Instead
last
of
project-
Python, use Rust.
Yeah, you'll have to use Rust. That's your last project. Satyam is unhappy. He would have said, why not Go?
No, actually, I was about to share that, people have gone crazy over this. So obviously the Golang purists are talking, there are things which is outperforming Python significantly. So all that they have done is taken just some of these vector implementations in Golang and all of this loading and unloading and all that kind of stuff. It apparently loads into the GPU much quicker.
Oh yes, definitely. I mean, see guys, here's the thing. Today you can do all of your AI in C++, but nobody wants to.
Exactly.
Like PyTorch and TensorFlow, both are C++ code bases. But so you have to find something that is a little bit more modern or recent. But see, I don't know, this is very, I find it hard. Has anybody coded, when was the last time people coded in C++? Like Who
Grad
coded
school.
last year?
Grad school.
Grad school. Oh my
I
God.
thought that was Java.
Mine
Guys,
was hybrid with.
Here's news for you. C++21 is amazing. Absolutely amazing and very different from whatever notion of C++ you have. It is so, there's a reason why companies like Google swear by C++. Right? C++ and Rust that has come now, if you want to go platform level performance, they're amazing languages. Go is amazing, right? Go, Rust, C++ are very, very fast languages. In machine learning, the two big languages that are upcoming are Julia, actually three big languages. Julia is very good, but it's getting a bit old now. The next is Rust. People are taking very seriously. And the third one is Mojo. Mojo is extending Python, but making it native.
Yeah, we want to complete the project in Mojo.
You want to?
No, by the time they have the release.
Yeah, we will. At this moment, it's beta, right? Invite
No,
only beta.
it's only supports Ubuntu actually, the SDK.
Okay.
If you want to, they are coming up with Mac, they already teaser.
Oh, okay.
Oh, it's out.
Oh, when I last looked at Mojo, it was just invite only.
No, it's available, you can go to site.
Now you can.
They claim 50,000 faster than Python, the speed, performance, I don't know, how is that? Huh? No.
Actually, being 50,000 faster than Python is very easy because Python is interpreted. Right. So that is, if let's say 50,000 times faster than Fortran or C, then I would be listening.
So Asif, nobody uses .NET anymore.
.NET. Oh, blast from the past.
Is Microsoft actually using it still?
Even Microsoft is. So, well, okay. C# I know is still active in the gamer community.
Isn't that a beautiful language? C# is like much better version than.
You use the right word. It was a beautiful language.
I've not used it many years, but I copied the Java syntax, made it nicer.
So, all right, guys, I'll just.
Asif, I have one more question, Asif. Sorry to keep extending the discussion. But I hear one of the advantages of vector database is you can actually selectively remove any bias from the data, right? So although I have some intuitive understanding of how it can be done semantically, it'll be good to hear your thoughts on that and maybe, have some practical hands-on in doing that using vector database.
Prepare. That's a very good thing. I know that there are statements like that. I haven't researched it well. Let me research and
Sure.
also learn something. But what you said reminds me, I've heard those things. Let me dig it.